Hi guys, in the previous lecture we have covered 3-phase half wave uncontrolled rectifier, that is the lecture number 16. Okay, and we have found V naught average, that is equal to 3 VML upon 2 pi, that can also be written like this, 3 into root 2 upon VL upon 2 pi, that is equal to 3 VL upon under root 2 pi. We found the output voltage, average output voltage of this half wave rectifier. Also we have seen the conduction angle of diode, and after that we found what is the average diode current and what is RMS diode current. Okay, now in this lecture we will start 3-phase half wave controlled rectifier, that is the lecture number 17. So let us proceed to the first slide. See, I have taken 3 thyristor T1, T2, T3 in place of diode. In the previous lecture diode is connected. So there I explained you the concept that when 3 diode are connected in common cathode configuration, then the diode whose anode potential is maximum will conduct. Okay, but here this is not the case. Here 3 thyristor is connected, so this thyristor T1 will conduct only when it is triggered. Is it fine? If I will not trigger the thyristor, then it won't conduct. But in case of diode, whenever the anode potential gets maximum with respect to other two, then that diode starts conducting, because the diode is known as uncontrolled divides. The turn on and turn off of diode is not in our hand, it is uncontrolled. It depends on the supply. But in case of thyristor, this is not the case. Thyristor starts conducting only when I will trigger the thyristor, otherwise it won't conduct. Now see here, I am taking omega t is equal to 30 as alpha is equal to 0. Alpha is the triggering angle, so alpha is equal to 0 is taken as at omega t is equal to 30. Why? Because for half wave diode rectifier, the diode starts conducting from omega t is equal to 30. So this is the point at which the conduction starts. That's why for thyristor we are taking alpha is equal to 0 at omega t is equal to 30. Is it fine? Now see here, I am giving supply, 3-phase supply across A, B, C, such that VA0 is equal to Vm sin omega t, VB0 is equal to Vm sin omega t minus 120, and VC0 is equal to Vm sin omega t minus 250. Okay, now see here, first I will draw the waveform of this 3-phase half wave control rectifier for alpha is equal to 0. See here, 3 thyristor are connected, means each thyristor will conduct for 120 degree, that is for sure. Why? Because in one cycle there is 360 degree. So for 3 thyristor to conduct in one cycle, it will be divided by 3, that is equal to 120 degree. So each thyristor will conduct for 120 degree. Now let us suppose I am triggering thyristor T1 at alpha is equal to 0, means T1 will starts conducting from omega t is equal to 32 plus 120, that is equal to 150 degree. Similarly, T2 is triggered at omega t is equal to 150. Is it fine? So when T2 will be triggered, then it will starts conducting from omega t is equal to 150 to 150 plus 120, that is equal to 270 degree. I know each thyristor will conduct for 120 degree, and this will happen only when there is continuous conduction mode. I will explain all the things, don't worry. Now see here, T3 will starts conducting from 270, because I am triggering T3 at omega t is equal to 272, it will conduct up to 390. Okay, so for alpha is equal to 0, this is the conduction period for T1 and T2 and T3 respectively. So if I will have to talk about for any kind of alpha, let us say I am triggering the thyristor for alpha, for any angle alpha, then T1 will start conducting from omega t is equal to 30 plus alpha to 150 plus alpha. Similarly, T2 will starts conducting from omega t is equal to 150 plus alpha to 270 plus alpha, and T3 will starts conducting from omega t is equal to 270 plus alpha to 390 plus alpha. I don't know what is the value of alpha. Here I am taking alpha is equal to 0, that's why I am getting like this. But for any alpha, that conduction angle of T1 will be 30 from 30 plus alpha to 150 plus alpha. Similarly for T2, 150 plus alpha to 270 plus alpha. It will conduct for 120 degree because I am using 3 thyristor and in one cycle there are 360 degree. So 3 thyristor I am using means 1 thyristor will conduct for 360 by 3, that is equal to 120 degree. That is for sure. Okay, so please note this. Now let us see. I am taking first R load. Okay, load is connected, that is resistive in nature. Is it fine? Now see, I am drawing the waveform for alpha is equal to 0. I already explained you. For alpha is equal to 0, see here, this is VA0, this is VB0 and this is VC0. And I have already told you this VA0, VB0 and VC0 are 3-phase supply given at the anode potential of thyristor. Now this thyristor will conduct only when it is triggered. So I am triggering this thyristor T1 at alpha is equal to 0, that means at omega t is equal to 30 degree. Okay. Now T2 is triggered at omega t is equal to 50 degree after 120 degree when T1 is triggered. That I already explained you. This is the triggering angle of T2 and this is the triggering angle of T1. Similarly, T3 will be triggered at omega t is equal to 270 degree, that is from here. Okay, this is the triggering angle of T3. Now see, when T1 will triggered and T2 and T3 are not triggered at omega t is equal to 30, that alpha is equal to 0, T1, I am triggering T1 only. T2 and T3 are not triggered means this will be open circuited, T2 will be open circuited and T3 both are open circuited. Only T1 will starts conducting like this. Is it fine? And it is connected to load that is having R load. For the time being I am taking R load only and this is O point, this is A point. So what will be the output voltage here in this case? The output voltage V0 will be VA0, that is equal to Vm sin omega t. Okay, so output voltage will follow the supply voltage VA0 when T1 is triggered. So T1 is triggered at omega t is equal to 30, that is alpha is equal to 0. So it will follow the waveform of output voltage VA0 and VA0 is shown as red marker. So it will follow like this, same as VA0. It will be maximum at 90 and again it will be like this at 150. So it will be the output voltage waveform from 30 to 150. I will get waveform that is equal to VA0. This is VA0 and in this case which thyristor is conducting? Thyristor T1 is conducting. Now what is happening at omega t is equal to 150? See, at omega t is equal to 150, I am triggering thyristor T2. So the moment when you will trigger this thyristor T2, then this thyristor T1 will go into the reverse bias and this T3 is not triggered. So no problem, this T3 will be open circuited because it is not triggered. I am triggering thyristor T2 at omega t is equal to 150 means T2 will be shorted and T1 will go into the reverse bias because the moment when you trigger this T2, the voltage drop across this T1 will be negative, so it will be in reverse bias and T2 starts conducting like this and this is the load connected here. This is V0. So in this case after omega t is equal to 150, I am getting output voltage from B point. This is A point, this is B point and this is C point. So V0 I will get that is equal to VB0. So output voltage will follow the supply voltage VB0. So after omega t is equal to 150, I will get output voltage like this, same as the waveform of VB0. Okay, this is the waveform of VB0 and it will continue till T3 is not triggered. So T3 is triggering at omega t is equal to 270. So before 270, I will get output voltage is equal to VB0. Okay. What will happen after 270? See, at omega t is equal to 270, I am triggering this thyristor T3. So when this thyristor T3 will trigger, then T3 will be short circuited. And the moment when T3 will be triggered, then this T2 will be open circuited and T1 is already open circuited. These two will go into the reverse bias. And here load is connected like this. This is the V0. Okay. This is C terminal, this is B terminal and this is A terminal, this is O. So in this case output voltage will follow the VC0, waveform of VC0. You can see here that our V naught is equal to Vc naught. I will get Va0 and Vb0 is open circuited. So output voltage will follow the Vc naught waveform like this, and it will continue till this point, because I already explained you that each thyristor will conduct for 120. So it will continue at omega t is equal to 390. So we can say that at a steady state I will get output voltage from 0 to 30 also like this, that is equal to Vc naught. Is it fine? So this is the output voltage waveform when alpha is equal to 0. Now here you can see that I have considered the R load. Okay, now let us say if I am considering RL load, means I am taking inductive load. So in case of inductive load also, output voltage will follow the supply voltage like this only for alpha is equal to 0. So for R type of load and RL type of load, at alpha is equal to 0, output voltage for R load is same as the output voltage for RL load. In this way we can draw the output voltage for alpha is equal to 0. Now see, for alpha is equal to 30 degree. Okay, for alpha is equal to 30 degree I am drawing the waveform. Let us say this is alpha is equal to 0. So alpha is equal to 30 will lie somehow here. This is alpha is equal to 30, that is equal to omega t is equal to 60 degree. Now see, I have already explained here T1 is triggered from 30 plus alpha to 150 plus alpha. So if I will take alpha is equal to 30 degree, then it will be T1 will conduct from 60 to 180. Similarly T2 will conduct from 180 to 300, you can find like this, and T3 will conduct for 300 to 420. Okay, this is the scenario. So I am triggering this thyristor T1 at omega t is equal to 60 like this, and T2 is triggered at omega t is equal to 180 like this, and T3 is triggered at omega t is equal to 300. This is the triggering angle of T3, T2 and T1. And I already said you the moment when you trigger the thyristor T1, then I will get output voltage from A terminal, because rest T2 and T3 are not triggered. So I will get output voltage from T1 when T1 will be triggered, and it will continue till the next thyristor is not triggered. So T1 we will get output voltage V naught is equal to Va0, because T1 is triggered at omega t is equal to 60 degree. So V naught will follow Va0 till 180 degree. You can see that after 180 degree T2 is triggered. So before T2 is triggered, T1 will conduct. So T1 will follow the Va0 waveform till 180 degree. So this is the Va0 waveform. So T1, this conduction angle means output voltage will follow the Va0 till 180 degree like this. This is the Va0, and here thyristor T1 will conduct. Is it fine? After 180 degree I am triggering T2. So the moment when you trigger this T2, T1 will go into the reverse bias and T3 is not triggered. So these two are open circuited, and T2 starts conducting at omega t is equal to 180, because I am triggering T2 at omega t is equal to 180. So the moment when you trigger this T2 at omega t is equal to 180, output voltage I will get from B phase. So in this case V naught I will get, that is equal to Vb0. So output voltage will follow the waveform of Vb0 from omega t is equal to 180 to omega t is equal to 300. Output voltage will follow Vb0, and it will continue to follow at omega t is equal to 300. See, at omega t is equal to 300, Vb0 is 0. So I will get output voltage like this. Now after omega t is equal to 300, I am triggering thyristor T3. Okay. So the moment when you trigger the thyristor T3, then what will happen? T3 will start conducting, it will be shorted. So in this case output voltage I will get, that is equal to Vc naught. Output voltage will follow the supply voltage coming from C point. So output voltage will follow Vc naught. Vc naught is like this. So it will be somehow like this, and it will continue to follow till 420, that we have already explained. So I can say that at a steady state, here from omega t is equal to 0 to 60, which thyristor will conduct? T3 thyristor will conduct like this. Okay, this is the Vc naught. Is it fine? So in this way I can draw the output voltage waveform for alpha is equal to 30 degree. Now here one question arises, the waveform of output voltage is for R load or RL type of load. See, if you will take R load, then also output voltage you will get same like this, and if you will take RL type of load, then also output voltage will be same, because here output voltage is continuous, it is not discontinuous for any angle. That's why for alpha is equal to 0 and alpha is equal to 30 degree, the waveform of output voltage is same for R load as well as RL type of load. Okay. Now see what is happening when I will take alpha is equal to 60 degree. Okay, see here, when alpha is equal to 60 degree, then tell me the conduction angle of thyristor. For alpha is equal to 60 degree, thyristor T1 will conduct from 90 to 150 plus 60, that is equal to 210. Okay, now thyristor T2 will trigger from 150 plus 60, that is 210 to 330 degree. So 270 plus 60, that is equal to 330. And thyristor T3 will trigger from 330 degree to 390 plus 60, that is equal to 450 degree. This is the conduction angle of thyristor T1, T2 and T3. Now what is happening? See here, for R load and RL type of load, the waveform will not be same. I can explain you like this. See, I am taking first for R load. Let us take, I am drawing the waveform for R load. I am not drawing the waveform for RL type of load. So see here, T1 will trigger from 90 degree. So where is 90? This is 90. I am triggering thyristor T1 here for alpha is equal to 60 degree. So T2 will trigger from 210 degree. I have already found. So this is the triggering angle of T2. This is the triggering angle of T1, and T3 is triggering from 330 degree. So this is the triggering angle of T3. Is it fine? Now see, I am triggering thyristor T1 at omega t is equal to 90 degree. Means this T1 will start conducting at omega t is equal to 90 degree, and it will continue to conduct till T2 is not triggered. So let us say here I am drawing the waveform. In this case, at omega t is equal to 90 degree, T1 is triggered. So output voltage will follow the input voltage, that is equal to VA0. So at omega t is equal to 90 degree, output voltage will follow the input voltage VA0 like this. Okay. Now see, for R type of load, voltage can never be negative. For R load, the output voltage can never be negative. In all the previous lecture, that is a single phase rectifier, we have seen that if I am considering the R load, then output voltage can never be negative. Output voltage is always be positive. Why output voltage can never be negative for R type of load? See, if output voltage you will make negative, means current I naught you will get minus V naught upon R, means I naught will be negative. If output voltage will be negative, means output current will be negative, and it is not possible to reverse the direction of current. Also, this thyristor won't allow the current to flow in reverse direction. This is the unidirectional device, so it won't allow the reverse direction of current to flow. So this is not possible for R load. You can see the all the previous lecture. For R load, V naught can never be negative, and here you can see that at omega t is equal to 180 degree, VA0 is equal to 0, and after omega t is equal to 180 degree, VA0 is going to be negative. So after 180 degree, V naught, this is V naught, will not follow the VA0 for R type of load, because output voltage can never be negative for R type of load. So after 180 degree, output voltage will be 0, and it will continue to 0 till the next thyristor is not triggered. And here you can say that the next thyristor is triggered, that is T2 is triggered at omega t is equal to 200 degree. So output voltage will be 0 from omega t is equal to 180 degree to 210. Are you getting me? So for R load, it is not possible that output voltage will be negative. So it will follow the supply voltage VA0 till 180 degree only. After 180 degree, it will become 0 till the next thyristor is not triggered. So the moment when you trigger the next thyristor, that is T2, at omega t is equal to 210 degree, then T2 will get shorted. Now in this case, thyristor T2 will start conducting at omega t is equal to 200 degree, and T1 will stops conducting because it will go into the reverse bias, and T3 is not triggered, so it will not conduct. So in this case, after omega t is equal to 210 degree, T2 starts conducting, so output voltage will follow the VB0 waveform. Okay, VB0 will come out into the picture, and V0 will follow the VB0 till omega t is equal to 300. See, at omega t is equal to 300, Vb0 is equal to 0, and after that Vb0 is negative. And we know that for R load, output voltage can never be negative, so this will conduct, T2 will conduct only till 300. After that, the output voltage will become 0 till the next thyristor is not triggered, and I'm triggering the thyristor T3 at omega t is equal to 330. So again, after omega t is equal to 330, output voltage I will get from this thyristor, because T3 is triggered at omega t is equal to 330. So output voltage in this case, after omega t is equal to 330, V0 will follow the Vc0, because T3 is triggered and it will be sorted. So from here I will get Vc0 like this, and at a steady state I can make like this. It will continue conduct till here, and from 60 to 90 it won't conduct. Okay, for RL type of load, it is possible that output voltage I will get negative, because RL inductive load will make the current continuous mode. So when current will be continuous, then output voltage will follow the supply voltage, because current is continuous. No matter output voltage will be positive or negative, it will follow the supply voltage, because I will consider for RL type of load I0 is constant. Is it fine? So for R type of load, output voltage I will get something like this. Now if I will have to make the waveform of RL type of load, then what is the modification here? What will be the modification in this? For alpha is equal to 60 degree, the modification will be like this. I said that for RL type of load, the output voltage will be negative, and we can consider that for RL type of load I0 is constant. Okay, so when I will take I0 is constant, means the output voltage will follow the supply voltage no matter whether it is positive or negative. So for RL type of load, what is the modification? We will get output voltage till the next thyristor is not triggered. So output voltage will follow the supply voltage here from 60 to 90 Vc0. The output voltage will follow the Vc0 like this. Okay, and from 180 to 210, output voltage will follow the Va0 like this. Okay, output voltage negative is possible for RL type of load. Okay, now from 300 to 330, output voltage will follow the supply voltage. Why output voltage will follow the supply voltage for any triggering angle? Because here I am considering that load is RL type of load, and in RL type of load I am assuming that I0 is constant, means for any time I will get the current. Okay, what do you mean by this? This means each thyristor will conduct for 120 degree, that is for sure, because I am assuming here that I0 is constant, means there is no any duration for which I will not get I0. I0 I will get for each and every duration. That's why the output voltage will follow the supply voltage for all time. That's why I am getting the waveform like this for RL type of load, or you can say that for highly inductive load. So what is the conclusion here? The conclusion is, for RL type of load, you can make any triggering angle, the output voltage will follow the supply voltage. See, for alpha is equal to 0 also, the output voltage is following the supply voltage that we have seen earlier. See, for alpha is equal to 0, for R type of load or RL type of load, output voltage is following the supply voltage, no problem. For alpha is equal to 30 degree, also for R type of load and RL type of load, output voltage will follow the supply voltage, and each thyristor will conduct for 120 degree. Now for alpha greater than 30 degree, what is happening? For R type of load, the output voltage is becoming discontinuous, but for RL type of load, output voltage will follow the supply voltage. So I can conclude that V0 is continuous for RL load for any triggering angle. No matter the triggering angle is what, the output voltage will follow the supply voltage, and each thyristor will conduct for 120 degree, that we have seen in this case. Is it fine? Now the second conclusion is, for R type of load, continuous conduction is possible for alpha less than 30 degree, that we have seen. For alpha less than 30 degree, or you can say that less than equal to 30 degree, continuous conduction is possible in case of R load. For alpha greater than 30 degree, output voltage will be discontinuous in case of R load. However, for RL type of load, for any triggering angle, output voltage will follow the supply voltage, and each thyristor will conduct for 120 degree. Got it? So this much concept you have to study in 3-phase half wave control rectifier. Now we will derive the average output voltage for different triggering angle. So what I will do, I will make one note and I will say for alpha less than 30 degree any kind of load. You can take any kind of load, output voltage will be continuous, that we have seen. Okay, so in this case what will be the V0 average? See, the V0 average I will get, that is equal to 1 upon time period, that is 2 pi by 3, and it is conducting from 30 plus alpha to 150 plus alpha, and it will follow the input voltage that is equal to Vm sin omega t. And remember, I have already told you that this Vm is maximum phase voltage. In the previous lecture I told you this, that Vm is maximum phase voltage. Okay, so after solving this I will get V0 average, that is equal to 3 root 3 Vm upon 2 pi into cos alpha, where Vm is the maximum phase voltage, and we know the relation between maximum phase voltage and maximum line voltage, that is equal to maximum line voltage VML is equal to root 3 times of maximum phase voltage. Okay, so I can also write like this, 3 VML upon 2 pi into cos alpha, where VML is the maximum line voltage. I can also write in terms of line voltage, that is equal to, we know that the maximum line voltage and line voltage, the relation between maximum line voltage and line voltage, that is equal to VML is equal to root 2 times of VL. So I can replace this like 3 root 2 VL upon 2 pi into cos alpha. In this way we can find the output voltage for alpha less than 30 degree, and this formula is valid for R load and RL type of load. Means also we can say that for RL type of load, for any alpha this output voltage is valid, because for RL type of load output current is continuous, means output voltage will follow the supply voltage for 120 degree duration and it will be continuous for any alpha. So we can say that for alpha less than equal to 30 degree for R load, and for any alpha for RL type of load, I can edit like this, for R load alpha less than equal to 30 degree, and for RL load you can take any alpha. Okay, so this formula is valid for this condition. So we don't need to derive the formula for RL type of load. For RL type of load this formula is valid for any triggering angle, but for R type of load this formula is valid for only when alpha less than equal to 30 degree. This means we have to derive the next formula for alpha greater than 30 degree for R load. Okay, now see the second point. I am deriving for alpha greater than 30 degree and only for R load. Okay, I am deriving the output voltage waveform. See, for alpha greater than 30 degree I am getting output voltage like this, red pen, this is the red pen output voltage I am getting only till 180 degree. After 180 degree output voltage will be 0 for R type of load. So I can write like this, the time period of this waveform is 120 degree. So it will be V0 average is equal to 1 upon 2 pi by 3, that is the time period, and this is conducting from 30 plus alpha to 180 degree. It will conduct only till 180 degree. After 180 degree it won't conduct, because after 180 degree output voltage or supply voltage is going to be negative. So it is not possible for R type of load negative output voltage. So it will conduct only till 180 degree. So I can write like this, it will conduct from 30 plus alpha to 180 degree and it will follow the Vm sin omega t d omega t, where Vm is the maximum phase voltage. Okay, now you can easily derive the average output voltage, that is equal to VML is equal to root 2 times of VL. So it will be root 6 VL upon 2 pi into 1 plus cos alpha. I derived the relation between maximum line voltage and maximum phase voltage in the previous lecture. So go through that. Similarly, you can find the output RMS voltage also. Only you have to do square the waveform and the time period will be same, and take under root, you will get the RMS output voltage in the same manner. However, for GATE exam, RMS output voltage is not important. That's why I am not deriving. Only you have to know the average output voltage. Got it? Now take the third point. In third point, we will see conduction angle of thyristor. Okay, so for alpha less than equal to 30 degree, each thyristor is conducting for 120 degree of duration. Is it fine? So for alpha less than equal to 30 degree, what is the conduction angle of thyristor? That is equal to 120 degree. So I can find IT average, that is equal to I naught. I naught is the load current into conduction angle of thyristor upon total time period, that is 360. You will get I naught by 3. Similarly, I can find IT RMS also, that is equal to I naught under root of conduction angle of thyristor upon 360, that is equal to I naught by root 3. Okay, and you can see that this IT average is equal to IS average also. See here in this circuit, the thyristor current is nothing but supply current. Okay, so we can say that the thyristor current is equal to supply current. So this will be equal to IS average and this will be equal to IS RMS for alpha less than equal to 30 degree. For R load or any kind of load, the conduction angle of thyristor is equal to 120 degree. Now what will happen for alpha greater than 30 degree? See, for alpha greater than 30 degree, for RL type of load, thyristor will conduct. Conduction angle of thyristor will be 120 degree only, because output voltage will be continuous in case of RL type of load. But for R type of load, the conduction angle will decrease. See here, for R type of load, the conduction angle will decrease and it will be from 30 plus alpha to 180 only. It will be from 30 plus alpha to 180 degree. So conduction angle of thyristor will come out to be 180 minus 30 plus alpha, that is equal to 150 minus alpha. Remember this point. For R load, the conduction angle will decrease. It will not be equal to 120 degree. But for RL type of load, for any triggering angle, the conduction angle of thyristor you will get, that is equal to 120 degree. So in this case, IT average is equal to I naught by 3. Same as above, and IT RMS will be I naught by root 3. But for R type of load, I am writing here, for R type of load, IT average I will get for alpha greater than 30 degree, I naught into 150 minus alpha upon 360, and IT RMS is equal to I naught under root 150 minus alpha upon 360 degree. This is for discontinuous conduction. Keep in mind, this is for discontinuous conduction, and discontinuous conduction is possible only when alpha is greater than 30 degree and R load is connected. Okay, so that's all about this lecture. In the next lecture, we will start 3-phase full wave control rectifier. So if you guys understood the concept, then please like this video and subscribe to this channel. For doubt solving, you can join our Facebook group. Thanks for watching this video.